Good afternoon, class. Today we're going to be looking at our spheres. Basically, we're going to look at shapes that are circles all the way around, no matter what direction I look at them. We're going to look at their surface area and their volume. So, before we get to the surface area and volume of it, let's look at a sphere. We had a few names for a circle. And we said that a circle is basically the set of all points in a plane that are the same distance from a single point. Well, a sphere is the set of all points that are the same distance from a given point called the center. So at the middle of the sphere is the center. Every point on it is the same distance away from that center. The radius, just like a circle, is from the center to the edge. So from the edge to the center of the sphere is the radius. A chord, just like a circle, it's a segment with two endpoints on it. So it could be from my two fingertips here. It could be from these two, from index finger to index finger, index finger to index finger, so on and so forth. As long as the segment is inside the circle with its endpoints on the surface, we're good to go. Now, a diameter is a chord that passes through the center. So from here to here is a diameter because it goes from surface to surface and it goes through the center. Basically, just like before, the diameter are two radii put together. The diameter is two radii put together. So, these words, we use them in circles. We're going to use them in spheres again. So, the first thing we're going to look at is the surface area of a sphere. Now, the equation for it is pretty straightforward. They just tell us straight up that the surface area is equal to 4 pi r squared. Your book does a pretty good of a job of explaining why this happens. But basically, when I would cut this up, what I would eventually get is the area that would be the same as 4 circles. So, the surface area is 4 pi r squared for a circle. R is still the radius. Wait, to find the surface area, all I need is the radius? Yeah, that's awesome. And also, the volume of the sphere, what we found is how much stuff that could be contained within it is 4/3 pi r cubed. Again, r is the radius. So if you know the radius or the diameter of this object, you can find its volume, how much stuff it can contain, and how much material is needed to create it, its surface area. So, what if I want to find the surface area and volume of a sphere with a diameter of 8 meters? Well, if I want to find the surface area and volume of a sphere with a diameter of 8 meters, well, if I want to find the surface area and the volume, I need the radius. Well, the radius is half the diameter, so the radius is 4 meters. Oh, so to find the surface area, 4 pi r squared, 4 pi 4 squared, so the surface area is 4 cubed, so 64 pi, and calculator time, 201.06 meters squared. Do the same thing for volume, but this time I have 4/3 in it, pi r cubed, so 4 cubed equals v. Well, this is going to be 4/3 pi times 64. And some of you might struggle with this part because we're multiplying fractions. So when I multiply fractions, I'm going to treat this as over 1. So 4 times 64 here, I believe is 264. Sorry, 256. So I get 256 over 3 pi. Now, to enter this in my calculator, what I'll officially do is I'll enter 256 times pi. Enter. Divide by 3. And if I enter it correctly, I get a number real close to 268.08 meters cubed, its volume. And there we go, that's how I find it. Also, let's do something that's a quick check. If I wanted to know if I was in the ballpark with my answer, here, if I multiply by a number real close to 3 and divide by 3, won't that kind of cancel out? So if I multiply by 3 and divide by 3, I should get a number real close to 256. I did. My answer is reasonable. Here, I'm doing a number around 65 times 3. So let's round that up, or round it down. 60 times 3 is roughly 180. Yeah, it's a little bit off, but I also dropped that number quite a bit, and I ignored that pi was 3.14. So ballpark estimates, yeah, I bet I'm right. So let's try this instead. What if instead of giving you the radius, and I'm basically just having you plug it in and solving, what if instead I tell you that the surface area is a certain number? And I want instead that you would find the diameter and the volume of the sphere. So I don't care about so much the surface area because they've told me it. They told me, hey, I know the surface area of this shape is 100 pi. They didn't give units, but I meant to say meters squared. And what I'm looking for is the diameter, and I'm looking for the volume. Well, I'm kind of at a loss here, but I know that I have the surface area. So let's look at the surface area equation. What if I just, for fun, plugged 100 pi into the surface area equation? So S equals, sorry, not S, because I know it's 100 pi. 100 pi equals 4 pi r squared. And I take a look at this equation. Wait a second. There's only one variable, r. So what if I got r by itself? I divide both sides by 4 pi. Well, the pi's cancel out. 100 divided by 4 is 25 equals r squared. Square root both sides, r is 5. Wait, I just found the radius was 5, which means the diameter is 10 meters. Oh, they also want me to find the volume. So the volume is that equation. Volume equals 4/3 pi r cubed. And I just found r, it's 5. So 5 cubed. 4/3 pi times 125. Again, what I'm going to do is I'm going to multiply and simplify a little bit here. I'm going to get the volume to be 500 thirds pi. And let's, I'm fine with this answer here. However, I'm going to punch it into the calculator. 500 divided by 3 times pi. And if I did this correctly, I'm again expecting a number real close to 500. And I would get a number that's 523.60 meters cubed. So, that's how I do this. Yeah, I might be working backwards sometimes. I might be going from surface area to the radius and using that to find the volume and or diameter. So, both ways for these problems shouldn't be too big of an issue. Now, there is something about circles that I haven't talked about. Not circles, spheres. If I look at a sphere here and I said, you know what, I'm going to cut it in half. Well, what I would get is this shape. See how it's half of my sphere? Yeah, it is. This shape here, if I cut it directly in half, this bottom here is called a great circle. Why is it a great circle? Because it's the biggest possible circle that you can create using a sphere. It's a circle that includes the center of the sphere. And the radius of the circle is the radius of the sphere. So, a great circle has a lot in common with the sphere itself. Is that this circle here has the same radius and same center as the sphere I started with. Also, this shape would be what I call a hemisphere. It's half of the sphere, hemisphere. Alright? So, hemisphere, half of the sphere. So, what is the area of a great circle of a sphere with radius 4 meters? Now I just got done saying that the radius of a sphere and the radius of a great circle have one in common. Well, I said if I would cut this exactly in half, this shape here is the center of my sphere. So the distance from the center to the edge is the same as the center to the edge anywhere in here. So the radius of this is the same as the radius of the sphere is the same as the radius of the great circle. So basically they just said, hey, r is 4 meters. I want you to find the area of the great circle. Is that the surface area? No, the surface area is for a sphere. That's definitely not volume. Wait, they're asking me to find the area of a circle? This is chapter 11, section 5 problem. Area equals pi r squared. That's the area of the circle. I know the radius is 4, so plug it in. Area equals pi 4 squared. And this answer I'm going to leave as that. It's 16 pi meters squared. There we go. So yeah, we have a new shape. Great circle. But it's going to have the same radius as the sphere. So most of the calculations are going to be pretty straightforward. Area, circumference. The last thing we're going to look at is a solid that really isn't a sphere, but it's not really a cylinder, it's not really a pyramid, it's kind of them combined. And I want to find the volume of it. So essentially what I have here, the volume of the rice, and the idea here is that I have a cylinder, and then the sphere is going to be the same height as the cylinder, so it's not exactly the same. But this volume isn't included in the volume I'm looking for. I'm only looking for the volume of the rice. So the volume of the cylinder, but not the volume of the sphere, or the hemisphere, I should say. So when I look at this problem here, what I'm going to have to do is I'm going to have to look at both shapes. This is how they had it drawn. And they said 2 inches here and 2 inches here. So basically they said the radius of this is 2 inches, and they said the height is 2 inches. But I'm really dealing with two different shapes here. I'm dealing with a cylinder and a sphere with radius of 2 inches. And what I want to basically do is I want to find the volume of this, and I want to find the volume of this, and what I'm going to eventually do here is I'm going to take the volume of the cylinder and the volume of the sphere, and I'm going to subtract them. So, if I look, the way to find the volume of the cylinder, if I remember correctly, it's pi r squared h. And the way to find the volume of a sphere is 4/3 pi r cubed. Now, this is a full cylinder, so I have no issues. I'm not changing the equation at all. But this is half of a sphere. Wait, it's half of a sphere? So then I'm looking for half of the volume. So even though that's a volume equation, I'm going to multiply it by half because I only want half of the volume of the sphere. So I look, r and h for both of them is the same. R is 2, h is 2. Wait a second. So to find the volume of the cylinder and to find the volume of the sphere, I basically plug in and solve. Oh, yeah, actually. Volume of the cylinder is going to equal pi times 2 squared times 2. Or the volume of the cylinder is going to equal 8 pi. This one here, the volume of the sphere is going to be 2/3 pi 2 cubed. So this is going to be volume of the sphere is equal to 2/3 pi 8. 2/3 of 8, volume of the sphere is going to equal 16/3 pi. At this point, if I'm looking for the volume of this solid, I kind of want an exact answer here. So I'm going to keep it in fraction form. If you wanted, you probably could get away with plugging in the calculator. But let's try and give an exact answer here. So the volume of the cylinder here is going to be 24/3 pi. This is 16/3 pi. So when I'm looking for the volume of my solid, I take 24/3 pi and 16/3 pi and I subtract them. 24/3 minus 16/3. Well, 24 minus 16 is 8. Thirds remain, so 8/3 pi. And that's all I have for you today. So a lot of this is just taking the equation and applying it in different situations. These are the equations to find the surface area and volume. It's really not that bad. But that's all I have for you today. Until next time.